Okay, finally, simplifying radicals, part 3. Now, we learned about multiplying radicals, putting two radicals that are multiplied together, separating them. Now we're going to learn about dividing radicals. So if we have a square root of two things divided, sometimes people think this is a fraction. Yeah, it's a fraction, but it's also it's also 36 divided by 49. Now, square root of 36 and the square root of 49 can be separated in division the same as they can be separated in multiplication, which means you have the square root of 36 for the top, which is just 6, and the square root of 49 for the bottom, which is just 7. So, if we have the square root of 144 over 9, we can break this down to the square root of 144 on top and the square root of 9 on the bottom. Square root of 144 is 12, square root of 9 is 3, 12 divided by 3 is 4. Now we can also take the square root of 144 over 9. So if we take square root of 144 divided by 9, we will get 4. This does not always work. It only works if both the things are perfect squares, if this is going to simplify into a perfect square. But why not try it? I mean, if it works, if it comes out to a perfect whole number, then we don't have to go through any of the other steps to try and get it to work out. All right, so let's try a couple more of these. Square root of 36a over the 4a cubed. So we have the square root of 36, the square root of a on the top, square root of 4, and the square root of a cubed on the bottom. Let's see, probably the easiest way to think about this is square root of 36 over 4. Square root of 36 is 6, square root of 4 is 2, 6 divided by 2 is 3. But we also have these a's to deal with. So we have the square root of an a on the top and 3 a's on the bottom. Well, an a on the top and 3 a's on the bottom, one of those will cancel. So we really have the square root of 1 over a squared. Well, a squared, the square root of a squared is just a. The problem is this is in the denominator. So we really have the square root of 1 and the square root of a squared. Well, the square root of 1 is 1, square root of a squared is just a, so we have 1 over a. But don't forget we had this 36 and this 4 to begin with, so we have 3 times 1 over a, which is 3 over a. Okay, I know these are a little bit confusing. Let's see, something else we could have done back here. 36 divided by 4 is 9. The square root of 9 is 3. So we could get the 3 part that way. We still got to look at these a's and think about canceling this a and one of these a's and still having the a squared in the denominator here, which means the square root of a squared, again, in the denominator is going to come out as just a in the denominator. All right, one more of these. The square root of 25, square root of y to the third, and the square root of z squared. Well, square root of 25 is 5. Y to the third is y squared times a y in the square root. Square root of y squared is just y. Square root of y doesn't simplify. And the square root of z squared turns out to just be z. So this is what we would get when we simplified that. All right, now that's not all for this third part. We also have to simplify, or rather rationalize the denominator. And what that means is if we were to end up with a square root in the denominator, we are not simplified. So same as if we have a perfect square left inside our square root, that's not simplified. Having a square root inside having a square root in the denominator is also not simplified. So for us to rationalize the denominator, it means we need to get the square root out of the denominator. Okay, no square roots in the denominator. The rule for us to do that is we multiply the top and the bottom by the denominator. All right, so simplifying, square root of 2 over the square root of 3. We could try putting this together, try dividing. Nothing's going to simplify here. Square root of 2 is as simplified as it gets, so is the square root of 3. But we know that we're not allowed to have a square root of 3 or square root of anything in the denominator. That's not simplified. Even if we try and put this back together, which some people do, and they say, oh, there's no square root in the denominator. Yes, there is. There's a fraction, which means you have a square root in the denominator. So we don't want to do that. So the rule up here tells us to multiply the top and the bottom by the denominator. The denominator is the square root of 3. So I'm going to multiply the square root of 2 times the square root of 3 and the square root of 3 times the square root of 3. So the top, 2 times 3 is 6, 3 times 3 is 9. These are still in square roots because we haven't taken a perfect square out. Square root of 6 doesn't simplify, but the square root of 9 is 3. And now we have our answer without a square root in the denominator. And this is called rationalizing the denominator. I'll do a couple more of those for you. Here we have square root of 5 is square root of 18m. The rule, multiply by the denominator on both top and bottom. So square root of 5 times square root of 18m gives us the square root of 90m, and the square root of 18m times the square root of 18m gives us the square root of 324 m to the second. But if we take the square root of 324, we actually just get 18. And if we take the square root of m to the second, we just get an m. So we have the square root of 90 m, square root of m, the m's inside still, over 18m. Now, we didn't have to do this in the last one. This would have been our answer. Can we cancel this m and this m? No. This one's in a square root. This is not in a square root. But we can probably simplify this 90 some. If I take the square root of 90 and make it 9 and 10, the square root of 9 is a perfect square. So this top can become 3 square root of 10 and m. Okay, remember that m was still in there. And then 18m. These m's, again, cannot cancel. This was in a square root. This is not. But the 3 and the 18 can because they are both outside the square root now. So 3 over 18 reduces to 1 over 6. You still have square root of 10m on the top and another m on the bottom. But this reduces to the 1/6. And this is what your final answer is going to be. Last one, square root of 7s over 3. Some people say this doesn't have a square root in the denominator. You don't have to simplify that. Yes, you do. The square root of 3 is in the denominator. Okay, it's a fraction, therefore it's in the denominator. So multiply by the denominator on top and bottom. Square root of 7s times the square root of 3 gives us 21s. Square root of 3 times 3 is the square root of 9. The 21s does not simplify. The square root of 9 is 3. And that does not simplify any further. The square root of 21 can't be broken down. There's no perfect squares in there that will come out for us. All right, so that is our part 3 of rationalizing the denominator. And these will take a little practice for us to get good at them.